Hello class, and welcome to our presentation on the template design pattern. This presentation is presented to you by Chase Busacker, Paul Nielsen, and Ben Smith. So the template design pattern requires there to be a template class which is an abstract class designed to be the cookie cutter for all of the other derived classes that will be using the template. Once this base class is built, there is a template function or a template method that is designed to put together the functions of all the other classes so that the code only really has to be written once. Once the abstract class is built, once the base class template class is built, we can also then have as many derived classes as necessary and only have to write certain code that changes them slightly, just derives them slightly from the original base class. This saves a lot of time and because it makes it so that the programmer doesn't have to write the code over and over again for the same kinds of things. And it's very useful for different objects that have similar parts to them. Now we have a real-world example to kind of demonstrate the template pattern. There are two recipes here, chocolate chip cookies and peanut butter cookies. If you notice, a lot of the directions are very similar. Both of them require the user to preheat the oven to 375 degrees. Both of them require the user or the cook to cream together certain ingredients such as butter and sugars. And then the next step is in both of the recipes is to add other ingredients such as eggs and vanilla or flour, baking soda, and salt. And then just in the chocolate chip cookie recipe, we also had chocolate chips, and then for both of them, we also place them on a baking sheet and bake for a certain amount of time and then cool them. This would be a very good example of a good use of the template pattern because both of these objects, we'll call them, both preheat the oven to 375 degrees. They both have the user cream together or add together ingredients, and they both place on a baking sheet, bake for a certain amount of time, and then cool for 5 minutes. And this can be written only once in a template class and then manipulated using the derived class. Now we will show you in some programming code what this may look like.
I want to demonstrate for you the template design method. What we have here is we're going to make instructions for the recipe. So you have the recipe in front of you, you got all your ingredients, and you want to create the instructions, but you want to have a program do it. So we're going to have a program do it. The program is going to tell you to preheat, it's going to tell you to combine the ingredients, cook the ingredients, and cool the ingredients. But what we can do with the template class is we can tell what we want to happen for each of the instructions and then create subclasses that can do each of those things, and then we can create some little differences that happen. So as you can see, for the preheat, combine, and cool, our instructions are going to say the same thing, but for the cook, they're going to say something a little bit different. So for the baked recipe, it's going to say bake, and for the cooked recipe, it's going to say cook on the stove. So let's go ahead and run this program and see what happens. So we'll enter 1 for baked, and then what it does is preheats the oven, you combine the ingredients, you bake, and then you let it cool. We can do it again, and this time we're going to put a 2 for cooked. And you can see that the difference is the preheat, combine, and cooler are the same, but this time it says to cook it on the stove. So that's something that you can do with the template design method.
Now that you have seen an example in real life and in some programming, we would like to go over some of the upsides of using the template design pattern. First, you can let clients override only certain parts of a large algorithm, making them less affected by changes that happen to other parts of the algorithm. This is very useful to protect certain information that we don't want to change. The template design pattern is also used to encourage clean design and code reusability. This is because we can actually avoid using duplicate code in multiple classes. Third, the template-based class outlines steps of an algorithm. It ensures that the steps are executed in the right order. So with the recipe example, each step in a recipe is always done. Cooking is always the last thing, second to last thing right before cooling. Fourth, the steps are actually hidden from the outside caller, which is useful when you don't want the outside caller to know the process. And finally, we can pull the duplicate code into a superclass like I mentioned earlier. This makes the code very clean and reusable.
A problem with the template design pattern is if you want to create a function outside of the functions already created in the abstract class for your subclass, then you're out of luck. It may be too difficult to fit your ideas into the provided skeleton. What I found difficult while creating the demonstration was trying to fit the idea of a recipe into this type of design method. In order to have this method create functions that could be inherited by subclasses, I needed to create different types of recipes. It will be much easier just to have one recipe class. There is no reason to create sub-recipe classes like beef and chicken recipe classes or baked and fried recipe classes. It just doesn't make sense for us. One other problem with this design pattern is template methods tend to be harder to maintain the more steps they have.
There are many reasons why someone would want to use the template pattern. First, someone wants their program to be open for extension and closed for modification. Secondly, when you're implementing content of a method or function, you can find some section of your code that varies from one type to another type. For example, when making a baseball and a basketball. They're both circles and they're both balls, but they are different colors and have different patterns. Finally, when you see a designer of a framework want your clients to use executable code that is passed as an argument to your framework, which is expected to call back and execute that argument at a given time. This execution may be immediate as an asynchronous callback, or it might happen at a later time in an asynchronous callback. One great example is the HTTP servlet. Finally, the template pattern allows the code to be very clean and organized, making it very easy to test. And these are our sources. Thank you for watching our presentation. I hope you enjoyed it.